in this session we are going to see numerical on fragmentation and reassembly, which is with respect to network layer. So we are having various functionalities of network layer like routing, fragmentation and reassembly, congestion control, end-to-end delivery, logical addressing. So like this we are having so many functionalities with respect to the network layer, but among them this is one of the important topic with respect to numerical perspective. So this fragmentation and reassembly, to understand this compulsory we have to aware of IPV4 datagram header format. We have to aware of IPV4 datagram header format. Okay, so this IPV4 datagram header format, if we are thorough about this, then we can easily answer these questions. So I am believing that you people are already aware of this IPV4 datagram header format. So that's why in this session I am focusing on only the numerical part of this particular fragmentation and reassembly of network layer. Okay, right. So coming to the question statement, a datagram of 4000, which is 20 bytes of IP header plus 3980 bytes of IP payload. So the total datagram size is 4000 bytes. So this is the total datagram size, and here 20 bytes of header length and 3980 bytes of data length. So with respect to the IPv4 datagram header format, we have an expression as part of the total length. So total length is equals to header length plus data length. So 4000 bytes of datagram is arrived at a router, in which out of 4000 bytes 20 bytes is the IP header and 3980 bytes of payload, means data part, is arrived at a router, and it must be forwarded to a link with an MTU of 1500 bytes. So what is the meaning of this MTU? So MTU stands for maximum transfer unit. Maximum transfer unit. Right. So how many fragments we need to allocate the data part of the original datagram? This is what the first question. So understand this. So I have an IP router. This is what my IP router, which has an MTU of 1500 bytes. And by default, this 1500 bytes of IP MTU, 20 bytes of header we are having and 1480 bytes of data we are having. So this is the data part and this is the header part. By default it is. And we must be very careful with respect to this data part. So why we are saying that we must be very careful about this data part, in the sense, whatever the value we are having as part of the data part of this MTU, that value should be divisible by 8. So why it should be divisible by 8 is because we are expressing the offset of every datagram. We are expressing the offset for every datagram, and this offset should be expressed in terms of 8 bytes. So that's why the data part should be divisible by 8. If this data part is not divisible by 8, then you have to choose the closest value which can be chosen, which can be divisible by 8. So 1480, if you look at that, 1480 is divisible by 8. So that's why I am not, there is no need of looking at the nearest value of nearest value to the 1480 which is divisible by 8. Reason itself, it is divisible by 8. So this is very, very important and very, very thin point. Okay. So whatever the data part we are having, whatever the value as part of the data part of MTU we are having, that value should be divisible by 8. Very, very sensible point it is. That should be divisible by 8 as we are calculating the offset for every datagram, or else for every fragment of datagram. And that offset is expressing in terms of 8 bytes. So that's why we are saying that it should be divisible by 8. The data part of MTU should be divisible by 8. Clear? Right. So now here to this router 4000 bytes of a datagram is arrived, which is divided into 20 bytes of header and 3980 bytes of 3980 bytes of data. So now this 3980 bytes of data, can I forward from this point to this point? No, because 3980 is higher value comparatively 1480. So, but I may unable to transfer total from this point to this point, but I can transfer out of 3980, I can transfer 1480 from this point to this point. So it means that out of 3980, if I have transferred 1480 from here to here, then what is the left data part? That is 2500. Then it is my first fragment. So what is my first fragment data part is 1480 bytes. This is my first fragment now. This is what my data length as part of my first fragment. Then after creation of first fragment, the remaining data part is 2500, but still this 2500 cannot forward from here to here as it is the higher value than 1480. Then, but out of 2500, 1480 I can transfer at a stretch from this to this point. So if I could minus this 2500 and 1480, then I can left over with 1020 bytes, so that I am able to create the second fragment. So what is the second fragment here? That second fragment is also having 1480 bytes of data. Then after creation of two fragments here, the remaining data part is 1020, which is less than 1480, which can directly forward from here to here. So it means that my third fragment data part is 1020 bytes. So total, to forward this particular datagram from here to here, this router is doing how many fragments? 3 fragments it is doing. So that's why the answer for the first question is option C. So 3 fragments are needed to allocate the data part of the original datagram. So these are the 3 fragments. And it is the first fragment, so that the first byte as part of the first fragment is 0, and the last byte as part of the first fragment is 1479. And this is the second fragment. As part of the second fragment, the first byte is 1480, because the first fragment is ended with the 1479, so that the second fragment will start with 1480 and it ends with 2959. So why I am saying that it is 2959 is, if you could say 1480 plus 1480, then it would be 2960, which is 0 to 2959, 2 fragments we have done. Then my third fragment will start from 2960 as the first byte, and the last byte would be 3979, because 3980 bytes of data part I have done. So 3980 bytes means 0 to 3979. So like this, 3 fragments we can create. Clear with me? Then coming to the second point. So what is the data size, coming to the second question, what is the data size contained in the last fragment? So how many fragments we have done? 3 fragments. Out of the 3 fragments, this is the last fragment in which I am having 1020 bytes. So which is matching with option A. Then it is asking me, the third question is, what will be the offset of the second fragment? So offset, how can I calculate? So now coming to the offset calculation. So if I know the offset value, then in order to find out the first byte, this is what another important very thin line point. So if I know the offset, then to find out the first byte of a fragment, I have to multiply the value of offset by 8. If I know the offset, then if I want to calculate the first byte of any fragment, then I have to multiply the offset value by 8. If I know the first byte of any fragment, then if I want to calculate the offset of that first fragment, then what I have to do? The first byte should be divided by 8. So that's why, what is the first byte here? 0, which is dividing by 8, so that the offset for the first fragment is 0. And the second fragment first byte is 1480. So if I know the offset, to find out the first byte, I have to multiply the value of offset by 8. Clear with me? If I know the first byte of any fragment, then to find out the clear with me. So if I know the first byte of any fragment, then if I want to find out the offset value, then the first byte is divided by 8. That is what we are doing. So I don't know offset now. So since I don't know offset, the first byte of the second fragment I am dividing by 8. So then 1480 by 80, if you look at, this is 185. Clear? Then come into the third fragment. So as part of the third fragment, the first byte is 2960. So to find out the offset of the third fragment, I should divide this first byte of the third fragment by 8. So then it becomes 370. So what is the third question here? What will be the offset of the second fragment? The offset of the second fragment is 185. But among the options, I don't have 185, so that option D is the answer for this question. So this is the way how to solve the numericals based on this fragmentation and reassembly of data link layer. It is network layer. Okay. So this is the way how to solve the numericals based on fragmentation and reassembly of network layer. I hope you are clear with my explanation. Thank you.